Okay, today we are working with our complex numbers again, our I, and we're going to be solving some equations today. Okay, so I have 3 examples here that you guys could look at if you wanted. I did want you to realize that none of these problems have an x. There's no x. There's an x squared, there's a constant, but there's not just a plain x. Same thing here. There's an x squared, there's a constant, there's no x. Here, same thing. There's an x squared, there's a constant, but there's no x. So if you'll remember back a few lessons, we learned that if there's no x, you can do this thing called the square root method. And so your goal is to get x squared by itself. So you keep doing things until x squared is by itself. And once x squared is by itself, that's when you square root both sides, slap down your plus minus, and then go from there. And then remember from the last lesson, if you have a negative under the radical, I is going to take that out, and then you'll go from there. So all of these 3 examples, we were doing the square root property because they had no x's. This one ended up coming out nice and pretty because 25 is a perfect square. This one, once we finally got x squared by itself, we didn't have a perfect square under there, so we had to break it down. What perfect square went in there, how many times? And this one, once x squared finally got by itself and we square rooted both sides, we ended up with a square root in the denominator, which you can't have. So this problem dealt with our our fancy form of 1. So we're going to see a mixture of these as we go through our examples today. All right, so looking at example 1, there is no x. So as long as there's no x, I can do the square root method. Okay, so my goal is to get x squared by itself. So typically when you solve equations, you get rid of addition, subtraction first. So we're going to get rid of addition of 48 by doing the opposite, which would be to subtract 48. So then the 3x squared is going to come down. The equals is going to come down. 0 minus 48 makes negative 48. My goal is still to get x squared by itself. So how do you think we'll get rid of that 3? We're going to divide by 3. You undo multiplication with division. So we're going to divide both sides by 3. The x squared comes down. If you can divide it, divide it. If you can reduce it, reduce it. And this divides and makes a negative 16. Okay, once x squared is finally by itself, this is when you square root both sides. And remember, the moment you square root, slap down your plus minus. On the left side, the squared and square root cancel, leaving x. And then remember from last lesson, we learned that if you have a negative under the square root, I is going to take it out, and then you'll be left with a positive 16 underneath. And then you just want to work on the radical. If you can take the square root of it, take the square root of it. If you need to break it down, break it down. If you need a foo. But this is a perfect square in this example, so it's going to come out nice and clean. And what's the square root of 16? 4. So our answer is plus minus 4i. And that's our answer, and we're done. Okay, number 2. Once again, there is no x. So, square root method it is. What are you going to do first? Add 150. We tend to always get rid of addition, subtraction first when we solve equations. So to get rid of subtraction of 150, we want to do the opposite and add. That negative 5x squared comes down. That equals comes down. And then 0 plus 150 makes 150. I'm still trying to get x squared by itself. So now what? Divide by negative 5. Very good. So I'm going to divide by negative 5. And then that leaves x squared. And then if you can divide it, divide it. And that divides nicely. 150 divided by negative 5 makes negative 30. And then to get rid of the squared, we're going to square root both sides. We're going to slap down our plus minus. On the left side, the squared and square root cancel each other, leaving x. And then remember, if you have a negative under the radical, I takes it out, and then you're left with a positive 30. And then you want to see what you can do with the square root. Can you take the square root of 30 and get something pretty? Nope. So then you want to be thinking about your perfect squares. So let's talk about them for a second. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 5 times 5, 6 times 6. Now, I don't need to look bigger at numbers bigger than 30. Can any of these numbers besides the 1 go into 30? Nope. So that's it. This is my answer. This is as good as it gets. Sometimes you can take the square root of something. Sometimes you can break it down. Sometimes you can't do either. All right, example 3. All right, once again, there's no x, just an x squared and a constant. So my goal is to get x squared by itself. What do we do first this time? Subtract 2. Very good. Get rid of addition with subtraction. The 8x squared drops. The equals drops. 0 minus 2 makes negative 2. Still trying to get rid of, or I'm still trying to get x squared by itself. So how do you get rid of the 8? You divide. So we're going to divide both sides by 8. Now, this doesn't divide nice, even if a lot of you think that that's negative 4. It's not negative 4. But it does reduce. We can divide both of these numbers by 2. So if we divide both of these numbers by 2, negative 2 divided by 2 makes negative 1. 8 divided by 2 makes 4. So it makes a negative 1/4. And then to get rid of the squared, we square root both sides. We slap down our plus minus. On the left side, the squared and square root cancel, leaving x. On the right side, I is going to take the negative out, and then we'll be left with the square root of a positive 1/4. Well, remember when the square root is over the whole fraction like that, it means that the square root is over the numerator and the square root is over the denominator. And lucky for us, these are both perfect squares. See? So as long as they're both perfect squares, it's going to come out pretty. What is the square root of 1? 1. What's the square root of 4? 2. And then the I comes down behind that. Remember how I goes behind the good-looking numbers, but in front of the square roots? But we don't have any square roots anymore because these are both perfect squares. So the square root of 1 made 1. The square root of 4 made 2. The plus minus just dropped, and the I just dropped. And that's our answer. Okay, we've got 2 more. Okay, looking at the next one. There is no x, so square root method. Here we go. What first? Subtract the 2. So to get rid of addition of 2, we're going to do the opposite and subtract. So the 3x squared drops. The equals drops. Negative 62 minus 2 makes negative 64. Don't square root yet. Sometimes people try to square root before they're supposed to. You have to get x squared by itself before you can square root. So how do we get rid of the 3? We divide. So we're going to divide both sides by 3. The x squared comes down. The equals comes down. Now, if you can divide this, divide it. If you can reduce it, reduce it. But it doesn't divide, it doesn't reduce. So we just leave it negative 64 over 3. Okay, once x squared is finally by itself, this is when you square root both sides. And the moment you do that, you slap down your plus minus. On the left side, the squared and square root cancel, leaving x. On the right side, who's going to take that negative out? I. And then we'll have a positive square root of 64 over 3. Okay, so now remember, this means that the square root is over the 64 and the square root is over the 3. Okay, I'm going to leave the plus minus I alone for a minute, but I can't forget about it. So anything you notice about what you see here? The 64 is a perfect square, so it's going to come out pretty. What is the square root of 64? 8. But you can't take the square root of 3, so that's still down there. Okay, but a few lessons back, we learned that you can't have a square root in the denominator. So if you ever have a square root in the denominator, this is when we want to find our fancy form of 1. And remember, the fancy form of 1 is whatever's in the denominator over itself, because you can't have square roots in the denominator, so that's why he becomes our fufu. Okay, at this point, we're going to multiply straight across, straight across. So 8 times square root of 3, you can't actually multiply those because he's under a radical and he's not, so it's just 8 square root of 3 over square root of 3 times square root of 3. Do you remember what that is? It's just a 3. It's square root of 9, but square root of 9 is just a 3. And I taught you a shortcut that when you take a square root times itself, that number gets to slip right out of the radical. Now, these guys you're not allowed to reduce because this is under square root and that's not. These guys you're allowed to reduce, but they don't reduce. Okay, so this is my answer. I just need to remember to get my plus minus I back in there. Okay, so it's going to go x equals plus minus 8. The I comes after the good-looking number, remember? And then recopy square root of 3 and all over 3, like that. And that's our answer. That one might have been a little overwhelming. Typically when students have to foo-foo, they get a little overwhelmed in general. Okay, one more. Example 5. There is no x, so because there's no x, we're going to do our square root property. So our goal is to get x squared by itself. So what do you think we're going to do first? Subtract 1. Okay. And then the 2x squared drops. The equals drops. And then what's 0 minus 1? Negative 1. Okay. Don't square root yet. You got to get Mr. X squared by himself. So now what? Divide by 2. So we're going to divide both sides by 2. So the x squared comes down, the equals comes down. You can't divide these, you can't reduce them, so it just stays a negative 1/2. Okay, so now the x squared's by itself. This is when you square root both sides, slap down your plus minus. And then on the left side, the squared and square root cancel, leaving x. And then on the right side, who's going to take that negative out of the radical? I is. And then you're left with the square root of a positive 1/2. Okay, so remember that square root that's over the whole fraction really means that the square root is over the 1 and the square root's over the denominator. Okay, so let's work on cleaning this up. Are either of these perfect squares? Yeah, 1 is. What's the square root of 1? Just a 1. Okay, but you can't take the square root of 2. All right, so let's clean it up. Remember, you can't have a square root in the denominator, so we need a foo-foo. Who is our fancy form of 1 here? Square root of 2 over square root of 2. Okay, now let's multiply straight across, straight across. 1 times square root of 2 is just 1 square root of 2, or just square root of 2, over. What's square root of 2 times square root of 2? Just a 2. If you take a square root times itself, shoop, out it comes. And that's because square root of 2 times square root of 2 is square root of 4, and the square root of 4 is a 2. All right, so now let's just get that plus minus I back in there, and it's going to go right here, plus minus I, because the I always goes in front of the square roots, but behind the pretty numbers. And I don't really have a pretty number unless I had written the 1, and then I could have put plus minus 1I square root of 2 over 2. And that's my answer. So this was solving equations with the square root method, where we have I because of the negative under the radical. And that's all for this lesson. Smiley face.